Hello, everyone. This is Professor Ma, and this is the sections on the language of functions. Uh, in a simple language, a function in mathematics is a formula, but in general, function is an important concept in mathematics and computer science. Okay. So we're going to talk about the general definition of a function. And the general definition of a function is a procedure, quote unquote, that assign each input exactly one output. So this is a little bit abstract. As we go on, it will be clarified. So well, here's an example. Okay. Here the inputs are driver's license number. And then there's some sort of procedure, a program can imagine that people use, or policemen use, or DMD use. Once you enter the driver's license number, you will pull out information of your name. So the input is the driver's license number, function, enter, output is a single name. And the important things about function is a procedure for each input, it produces exactly one output. So in this sense, this input driver's license number, output the drivers corresponding to the license. This is a function. This entire process constitutes a function. And because you only assign one owner to the license, and then on the other hand, if a procedure where you feed in the license number, it pull out all the people that's related to that driver's license, of that person, of the license holder. Pull out all the siblings, cousins, and uncles, the whole batch of them. And then in this case, it's not exactly one output, it's many multiple output for that single input of driver's license number. So this procedure we consider is not the functions. This procedure is more complicated. Function is very simple, one input, one output. And later, we in general in mathematics for different procedures or different function procedures, we will use a letter F, little letters, small case f, g, h to name these the functions. And one thing very important about is the domain of the functions. Okay. And the domain of a functions is what inputs it takes. And in the examples of the driver's license number to the license holder, the input it takes is valid driver's license. Therefore, the domain of this license number functions is the set of all license numbers. And that totality is called the domain. Valid license number. And the output are, of course, the license that all the drivers with a valid driver's license. And so those sets of outputs, we call them rings. And there are many ways to express functions. One way is to make a table. If we make a table, then the left-hand side, the x over here is the input, and the right-hand side is the corresponding output. So this table explicitly tells you if the input is -1, the output is 4. It's a list. And so, and the things I can correspond things to real life of this table is a menu. You go to McDonald's, there's a menu. And the input doesn't have to be numbers. The input could be hamburger, $2, fries, $1.50, and chicken McNuggets, blah blah blah. So one input, one price. Okay, so that's menu are functions. And this, so in other words, tables like this are functions, where for one input and there's one. For each input, there is a output as one single output associated to it. And the other ways to express functions, I can give functions as pictures, as graphs. And then I let you read through these. You can pick out where the domain is, what inputs are, and what the outputs are. There are two different functions here. One is the average gas price, and one is the inflation adjusted gas price. Oops, do those. So, but since we are interested in functions mathematics are formulas. So, and the notation is in this is given in these manners. So let me break it apart. In this case, the f is the name of the functions. On a paper, there might be many formulas, and I want to talk about different formulas. And there's this formula f. There might be another formula that looks different, and instead of keep writing the formula down, I'll give a name, FGH. So this is formula F. That's a name. And it followed by an input box. This is now multiplication, very important. This is a box to hold inputs and takes inputs. And then followed by what exactly the function do as a mathematical formula, and that's what f does to the x. And then finally you have the output, which we call 1. Okay. And so if the input box not incoming, the input is 2. So we take 2 and process by f. So take 2 and slot into where the x is. Replace now the input instead of x is 2. So put it in there in this manner. And then this will give you an expression which we can calculate. In this case, comes out to be 3. Then the output for 2 is 3. Okay. In this case, I can put in any number. So the domain of this formula f is all real numbers. I can plug in any real number. It will compute and it will give me the answers. Okay. Let's get. Here are some more examples and of how we can use this notation to give instructions. And this one is asked you to plug in -2. And now on this page, there are 2 different formulas. So the instructions, the examples coming out will ask you to calculate depending on the symbols. You have to choose the formula. This one, you have to calculate f of -2. So you take -2, you plug in for the x. And very important step, the inputs put it into the formula, and then you calculate the output. You can do these things, then for the same thing for g of -2, except you have to put in the formula g, which is the other form. So put the -2, copy in the x, and then you calculate that, and comes out to be -1. Now I can combine these 2 answers. So this expression now makes sense. I'm asking you to take f of -2, which is this, which comes out to be 3. And take g of -2, which is of course this, comes out to be -1. And the question is asked you to subtract 2 outcomes. One, the outcome from the f, the outcome from the g, subtract them for some purpose. But this is an illustration of what we can do with these symbols. And have a constant function which will only produce single numbers all the time. Domains. And there are 2 things about domains, 2 kind of formulas. One's fractional formula, denominator cannot be 0, and or square roots. And in the square root, you have to have the radicand. the numbers to be square rooted, you have to have that number bigger than or equal to 0. So for the fraction, denominator cannot be 0. So the domain can be every number except the minus 3. Okay, so if somebody want to use this formula, you have to have a disclaimer saying, oh, you cannot use minus 3. The formula will not, it's undefined at that number. Same thing for this, you have to have the radicand bigger than equal to 0, which is an inequality. And this tells you x has to be bigger than minus 3. So in this case, the domains, you can only use number that's minus 3 or larger. If you take a number smaller than it, you will not calculate because you're going to take square root of negative values. So you won't pass. Okay. Once we have this notion of functions, then I can make a graph of function by setting the y in the xy coordinate, setting the y coordinate to be the outcome of the x. And so if we have the formula f of x equal to x plus 1, then I can set up a table and calculate for input x and the corresponding output y. Okay, this. And I can plot this point 0, 1, 1, 2, 2, 3 input output as a coordinates, and they line up. And then if you think about it, so to plot every number's x between 0 and 1. So I got all the points in between. And what I wonder is it's a line that goes through those points. So that's the graph of y equals x plus 1. I can do this for every formula in the function form. We have y is equal to some formula x. I plug in the x, I get a y, plug in another x, get another y, I plug those points. That's called plotting, graphing. Okay. And here's an example of not a functions in terms of formula. So we'll talk about that later. Okay. Yes, when we come to our equation, we'll come back to this. Okay. And we can read about it. And that's it. Yeah, I do want to take a look at the homework. These are different ways of presenting functions. And for instance, these are two tables. And ask you which table is a function. Well, this is not a function. Why? Because it gives you two different outputs for the same input too. It's like if you go to a restaurant and it says hamburger $4, next line hamburger $3, and you scratch your head, which one is it? I mean, how much? Because a single input has multiple outputs. This is not a function. Okay. So this is an example of a table that's not a function. And another thing about functions is I can plug in, for example number 14 here. The input doesn't have to be number. I can actually plug in a formula. So I can take formula 3 plus a, say ask, and input this into the formula G. So here's formula G. So what you have to do is, first of all, you have to calculate, put 3 plus a into for the x. So it becomes minus 3 plus a squared plus 3 times x, 3 plus a, okay, minus 2. You see where the x's are? They came out, and they all becomes what? 3 plus a. with the rest of the formula doesn't change. These, of course, could be expanded in this comes out like minus 6a, yeah, you know, 6 squared plus 9 plus 3a minus 2. 9 cancels. So equal to minus a squared minus 3a minus 2. Okay, I didn't make any mistakes. Be careful. This is different from g of 3 plus a. Okay. What's g of 3 plus a? G of 3 plus a asks to take g of 3. So you put 3 into g. If you put 3 into g, you're going to get minus 2. Okay. And so g of 3 plus the a outside the parentheses, plus the a's afterwards. So in this answer, then that will be just minus 2 plus a. So be careful when you read the instructions of the homework exercise. Okay, do the homework and see you next time. Bye-bye. Okay, that is stop and end.